This is number 86 in Chapter 8. It's looking at determining chemical reactions based on reactivity. We've now talked in Chapter 8 about effective nuclear charge, ionization energy, electron affinity, right, and how we can predict elements that would rather lose electrons compared to elements that would rather gain electrons. And so that's what this question is talking about. It reads, based on the ionization energies of the alkali metals, which alkali metal would you expect to undergo the most exothermic reaction with chlorine gas? Then write a balanced chemical equation for the reaction. So really what it's asking is that we're going to take some type of alkali metal, a group 1A metal, and we're going to react that with chlorine gas, and which one is going to produce the most exothermic reaction, right? And so we're basically looking at, hydrogen versus lithium versus sodium versus potassium versus rubidium versus cesium versus francium. And so we think about the process. We know that from our group 1A metal we need to have a positive charge. We know from our chlorine's a nonmetal, those guys like to gain an electron, because ultimately what we have as a solid here is going to be a partnering of a plus and a minus charge to make some type of salt, to make some type of solid salt. So if we're talking about giving an electron to chlorine, we're talking about electron affinity. And that's going to be a constant for this reaction because we're always talking about chlorine. And chlorine likes to gain an electron. It's a nonmetal, and so we would have a negative electron affinity for chlorine. And so the real question is about the group 1A metal and its positive nature. And so that's going to be ionization energy. And while electron affinity is negative, ionization energy is positive. Electron affinity, remember, is the energy released upon gaining an electron. Energy released, so that's a negative value. While ionization energy is the energy required to remove an electron. And so it's energy required or it's positive. So the real question is which one of these group 1A elements has the lowest ionization energy? Because the one that is the lowest would be the one that's electron is easiest to remove. And so since it's easy to remove that electron, it would result in the most exothermic reaction because there's not a large contribution required by the ionization energy. And so remember, ionization energy increases as we go up the periodic table, and so that means francium would have our lowest ionization energy. It would be the easiest to ionize, and so really we're looking at francium plus chlorine gas to give us francium chloride as our solid salt. And if we balance this out by putting a 2, we have our balanced chemical reaction for francium reacting with chlorine gas, which would be the most exothermic reaction of all the group 1A metals and chlorine gas reacting together. That is number 86.